Amid the powerful wave of aviation growth across Southeast Asia, Vietnam is emerging as one of the region's fastest accelerating destinations, where demand for mobility, trade, and international connectivity is expanding at an unprecedented pace. Right here in Vietnam, a mega project known as Thanh International Airport is gradually taking shape across more than 5,000 hectares, with an investment of 16 billion United States dollars and a planned capacity of 100 million passengers per year, placing it among the largest airports on the planet. This is not merely an infrastructure project, but a strategic leap that could reshape the regional aviation map, redefine trade flows, and move Vietnam into the intense competition for Southeast Asia's transit hub position. So what is truly being placed at stake behind this massive project? Today, Mandarin Tech will take you inside the full story behind the Long Thanh Mega Airport project. For many years, Thanh International Airport has operated far beyond its design capacity. Approximately 40 million passengers per year pass through a system that no longer has room for expansion, as it is surrounded by the dense urban fabric of Ho Chi Minh City. The challenge is not limited to terminal overcrowding, but also includes pressure on air traffic management, transportation infrastructure, and operational safety. Meanwhile, Vietnam's tourism industry continues to grow strongly. In the first quarter of 2025, international arrivals increased by approximately 30% compared with the same period of the previous year, ranking among the highest growth rates in the Asia-Pacific region. At the same time, Southeast Asian countries are entering a race to build aviation mega-hubs. Singapore is expanding Changi Airport to handle 150 million passengers per year. Malaysia has Kuala Lumpur International Airport. Thailand operates Suvarnabhumi Airport as Bangkok's main aviation gateway, and the Philippines is developing Bulacan International Airport as a new regional transit hub. Vietnam cannot remain outside this race. Long Thanh is therefore not only intended to relieve congestion at Tan Son Nhat, it is planned as Vietnam's new international transit hub, marking a transition from an urban airport to region-scale strategic aviation infrastructure. Approximately 40 kilometers to the east of Tan Son Nhat Airport, the Long Thanh area was once characterized by red basalt soil, rubber plantations, and long-established residential communities. To create a mega airport, the first step was site clearance and the complete restructuring of the existing landscape, with around 4,800 households relocated. The project then entered the ground treatment phase, a critical engineering challenge due to high soil moisture and limited natural load-bearing capacity. Hundreds of millions of cubic meters of soil were excavated, leveled, and reinforced, while an underground drainage system was constructed to ensure a stable foundation for future runways and terminal buildings. The large-scale landfilling process also generated significant red dust, particularly red basalt dust that could spread for several kilometers and affect surrounding residential areas. To limit dust dispersion, contractors implemented environmental control measures, including excavating 10 water retention ponds and maintaining continuous moisture spraying across the entire construction site. All of these processes laid the first foundation for the future development of Long Thanh International Airport. Long Thanh is not planned as a single terminal building. It is designed as an aerotropolis, a multifunctional aviation city. The entire area, covering 5,000 hectares, includes 4 passenger terminals, 4 runways each measuring 4,000 meters, a large-scale aircraft parking system, a logistics and cargo center, and supporting service areas. The central terminal is inspired by the lotus flower, the national symbol of Vietnam. The space is organized in an open structure, integrating water features, parks, and multi-level transportation systems. The construction process is divided into 3 long-term development phases. Phase 1 focuses on the construction of a passenger terminal with an area of approximately 373,000 square meters, consisting of 4 functional levels ranging from technical operations to commercial waiting lounges. The design targets the 4F standard, the highest classification allowing accommodation of the world's largest aircraft currently in operation. The total investment for Phase 1 is estimated at approximately 4.6 billion United States dollars, including the construction of the terminal, the first runway, aircraft parking areas, technical infrastructure, and major supporting facilities. At the same time, an elevated roadway is being constructed to directly connect the terminal area with the external expressway network, separating traffic flows and reducing congestion when the airport operates at high capacity. After the master planning phase, the focus shifts to takeoff and landing infrastructure, the operational foundation of the entire airport. When the Long Thanh construction site was still covered by rubber plantations and red basalt soil, the runway area had not yet taken shape. Before any concrete was poured, the first step was to precisely determine the runway centerline axis. Once boundary markers were established, the entire area was stripped of surface soil and leveled according to the designed elevation. This work was carried out across a strip of land stretching several kilometers, requiring high precision to ensure a uniform foundation before moving to ground reinforcement. Weak soil layers were treated, backfilled, and compacted repeatedly until the required stability was achieved. When the ground met technical requirements, the runway gradually became visible as structural layers were formed step by step. From a distance, the construction site transformed from rough red earth into a straight, sharply defined structure, cutting through the vast landscape. At the same time, the taxiway system was constructed in parallel, forming an integrated network connecting the runway, aircraft parking stands, and the central terminal. After the runway surface was completed, the lighting system was installed along the runway edges and the landing centerline. Lighting equipment, signage, and navigation support systems were tested simultaneously before trial operations began. The lighting trial operation and calibration phase marked the transition from construction to operational readiness. In parallel with the airside infrastructure, construction of the passenger terminal was also carried out on a large scale with high technical requirements. After completing the deep foundation works and primary load-bearing structure, reinforced concrete blocks gradually took shape, defining each functional level of the terminal. Thousands of workers and construction machines operated continuously to erect the structural framework, install mechanical and electrical systems, and complete the internal technical spaces. This process required close coordination between architectural design, structural engineering, and aviation operational requirements to ensure construction progress and synchronized commissioning of the facility. Within the structure of the central terminal, the dome roof is the most technically complex and symbolically significant component of Long Thanh International Airport. More than 5,300 tons of steel are assembled into a multi-layer curved spatial structure covering nearly 20,000 square meters, connected through 256 connection points to form a massive load-bearing frame capable of distributing loads evenly and maintaining stability under strong winds, as well as temperature variations. Not only serving an architectural role, the roof system is also designed as a technical envelope protecting the entire terminal space. The curved structure optimizes long-span coverage, reduces the number of interior columns, and creates an uninterrupted space that allows continuous passenger flow. Beyond aesthetics, the roof must also meet technical standards for corrosion resistance, drainage performance, and long-term durability required of a modern international airport terminal. When completed, Long Thanh Airport's roof becomes a technical landmark, demonstrating large-scale steel structure design and construction capability, marking a new advancement in Vietnam's infrastructure engineering. Inside the terminal, the space is organized according to a modern layout, with check-in areas, security screening, commercial zones, and waiting lounges arranged in a continuous flow to optimize passenger movement and reduce processing time. Intelligent operational systems combined with integrated technical infrastructure enable the airport to handle tens of millions of passengers each year, forming a large-scale aviation operations hub that meets international operating standards. In a modern airport, passenger boarding bridges are not merely connection devices, but a critical link within the entire operational chain. At Thanh Airport, the bridge system is designed to accommodate a wide range of aircraft types, from narrow-body aircraft operating domestic routes to wide-body aircraft serving intercontinental flights. Each boarding bridge is a complex mechanical structure capable of rotating according to parking position, adjusting vertically to match aircraft door height, and extending along the aircraft fuselage. As a result, passengers can move directly between the terminal and the aircraft, helping reduce aircraft turnaround time and maintain continuous operational flow. These structures, though seemingly modest, are in fact key elements determining the overall operational efficiency of the airport. Directly connected to the passenger boarding bridge system is the aircraft apron, comprising a total of 40 aircraft stands, including 5 domestic aircraft stands and 35 international aircraft stands. These expansive concrete apron areas, covering hundreds of thousands of square meters, function as the transition zone between the terminal and aircraft operations, where refueling, baggage handling, and pre-departure preparations are carried out simultaneously before each flight. Within the entire operational system of Thanh Airport, the air traffic control tower is considered the brain that governs every movement. The air traffic control tower, standing 123 meters tall, rises above the vast airport landscape, serving as a strategic observation point overseeing the entire operational area. The tower shaft has a diameter of approximately 10 meters, designed to be slender yet stable. The control cabin at the top covers nearly 150 square meters and is equipped with modern display and communication systems. Radar installed at the summit enables wide-range aircraft monitoring, supporting precise approach and landing control. With a total investment of approximately $140 million, the air traffic control tower is not merely a high-rise structure, but the coordination center of the entire airport, ensuring all operations are conducted safely, accurately, and continuously. Surrounding the entire area is a perimeter fence system extending 8,668 meters. Within an airport covering 5,000 hectares, a physical boundary is essential to ensure security. This system integrates cameras, sensors, and access control. Protecting technical zones, fuel storage areas, and runway zones requires high security standards. The fence may not be architecturally impressive, but it is an indispensable component in the operational structure of a mega airport. At Thanh, the refueling system is designed based on a modern underground fuel supply model. Fuel is stored at a central depot consisting of 6 above-ground aviation fuel tanks, each with a capacity of approximately 6,000 cubic meters. From this facility, fuel is transported through an underground pipeline network running beneath the aircraft apron, directly connecting to individual aircraft parking positions. Alongside the fuel system is an underground utility tunnel network located beneath the terminal area and apron, where the main operational infrastructure lines are concentrated. Placing the entire technical system underground keeps the airside surface unobstructed, ensuring stable and safe airport operations. Thanh is a project requiring financial resources on a scale rarely seen in the history of Vietnam's infrastructure development. When all phases are completed, the total investment could reach tens of billions of United States dollars. This figure is large enough to generate intense debate, especially as the aviation industry previously fell into crisis during the COVID-19 pandemic. At a time when global air traffic declined sharply, many questioned whether investing in a mega airport was overly risky. However, rather than being implemented all at once, the project was divided into 3 phases, allowing adjustments based on actual demand and the pace of market recovery. In addition, construction activities created direct impacts at the local level. Large-scale land leveling caused red basalt dust to spread widely, covering nearby residential areas and surrounding orchards. Many households in the surrounding communities reported that fine dust affected daily life and raised concerns about respiratory health, particularly during peak construction periods. For this reason, water spraying measures, reservoir construction, and vehicle control systems were implemented during the foundation stage to minimize dust dispersion, although the initial impact still left a noticeable mark. Long Thanh is first and foremost a practical solution to the congestion challenge in southern Vietnam. Once operational, the airport will reduce pressure on Thanh International Airport, improve operational efficiency, shorten waiting times, and expand the ability to open additional long-haul international routes. In addition, the establishment of a major aviation hub will generate demand for technical services, aircraft maintenance, aviation workforce training, hospitality, transportation, and commercial activities. This development will create new employment opportunities and stimulate investment in Dong Nai province and neighboring regions. If it reaches its full operational scale in the future, Long Thanh will not only increase the number of flights but also expand the economic development space for the entire southern region. Its significance, therefore, lies not in passenger numbers alone, but in the ability to create infrastructure large enough to support long-term growth. From the red basalt ground of 2020 to today's modern mega construction site, Long Thanh is gradually transforming into a new symbol. Challenges related to schedule, cost, and regional competition still lie ahead. Yet every steel beam installed and every meter of runway completed shows that Vietnam is ready to invest in infrastructure on a global scale. And if you want to continue following the mega projects reshaping the modern world, don't forget to subscribe to the Mandarin Tech channel and turn on notifications so you won't miss the latest analyses.